Now, if we change that direction and we cut perpendicular to the base, in our case, if the base is at the bottom, we're going to rotate that plane so we're cutting straight up and down. Okay? So again, in this case, regardless of how we rotate it, that cross section that we see on the inside, highlighted in orange, is also a rectangle. Alright, and then the third one is if they want it kind of slanted to the base, so almost like if we tilted it. Now, there are a few different ways that you can think about it. If we're talking about slanted so that it's going like edge to edge, like it is here, then it's definitely a rectangle. Alright, but we could obviously continue to rotate further and it becomes more like a square, or I could scoot that plane closer to the top or to the bottom and notice it's still a rectangle, but it changes in size, okay? So for our case, in either way we look at it, it's still a rectangle. It would just vary in size, okay? All right, next shape, we have a cylinder. Our base is obviously here, 2 circles. All right, so cross section of a cylinder. So again, if we're cutting parallel to the base, then if our bases are top and bottom, we're essentially cutting through the middle so that our plane is also parallel to the top and bottom. So again, we can adjust anywhere. We could turn it side to side, but if we're cutting flat across, we are seeing a circle, just like the top and bottom. And if it helps, you can almost kind of visualize looking at it this way. If we were to turn it over on its side so that you can kind of see it looking down on the cylinder. Okay? Alright, if we take that plane and we rotate it vertically so that we're cutting perpendicular, notice how we end up with a rectangle. And a rectangle is almost like, it's like what the shadow of a cylinder would look like. Like if we were to put a sheet in front of a cylinder and only look at it like a silhouette, that outline, if we can't see the curves at the top, looks very similar to a rectangle. Okay? The last one again is if we take it and we go slanted. So again, depending on how slanted you go, in this case, that's kind of a rectangle, but it's also kind of a strange shape. I like to think about it more as if we were to cut it slanted kind of like this, we can see that that's similar to a circle, but it's more like an oval because it's got to be stretched, okay? So similar to the base, but a little bit longer because it's obviously got further to go if we're going slanted versus just going side to side, okay? All right, third shape. We have a pyramid. In our case, the base is a rectangle. We don't necessarily know that that's a square. So a rectangular pyramid. All right, so sitting upright, just like ours on our picture. If we cut parallel to the base, you can see if it helps to rotate it, okay? Parallel to the base, we have another rectangle. All right, if we turn that plane up and instead go vertical through the vertex at the top, we end up with a triangle. Now this one is also kind of different as well because we could really, well no, we have to be perpendicular to the base. Where it gets a little iffy is when you go slanted. So again, if we slant a little bit, notice that we're kind of seeing a four-sided figure, not really a kite, but it's just kind of a general quadrilateral. If I continue though to stretch, still kind of a four-sided figure. In this case, still a four-sided figure, but they all look different, okay? So it kind of just depends on how you're cutting. I would just think about it more as either weird quadrilateral Or sometimes we can end up with what kind of looks like a rectangle depending on how we rotate it, okay? But in general, just say quadrilateral. All right, for the next one, we have a cone. Base is obviously a circle. All right, so again, parallel to the base, we have a circle, just smaller than the base. If we rotate that plane straight up and down so that we're cutting perpendicular to the base, we have a triangle. And then if we take that plane and we slant it, again, depending on how much you slant, notice here it's almost just kind of like a dome shape. But if I continue to slant, now it's more like an oval, okay? So I like to think of it pretty much as an oval. That's what I tell most of my kids. So I would even say if we cut it at an angle similar to that, it's more like an oval. Obviously, the steeper our angle, it's going to look more kind of just like a dome shape, similar to that. Okay, real rough sketch, but similar. All right, and then the last one, we have a sphere. And we really could probably do this one without looking at the GeoGebra app, but obviously in a sphere, regardless of how you rotate, every cross section is going to be a circle. Okay. All right, so if we look back kind of at the ones we've done so far, hopefully some things you notice kind of looking back at your chart is that anytime we take a plane and we cut parallel to the base, notice how your cross section is the exact same shape as whatever the base is, with the exception of a sphere that doesn't have a base, but they're always circles, okay? When we cut perpendicular to the base, the cross section we get looks kind of like the lateral face. So if we were to highlight, again, kind of the silhouette, what does just the general outline of that shape look like? So for pyramids and cones, your general outline is mostly like a triangle, versus for cylinders and prisms, your general outline looks more like a rectangle, okay? And then anytime we cut slanted to the base, we basically take the shape of the base and make it longer. We kind of tweak it a little bit. So like the cylinder has a circle base, it becomes more like an oval. Or the prism had a rectangular base and it just became a longer rectangle, okay? So we could add that here, kind of at the top of the next page. So when we cut parallel to the base, same shape as the base. If we cut perpendicular to the base, the pattern that we notice is that it looks like the lateral face. And I'm even going to say like silhouette. Okay? And then if we take it and we cut slanted to the base, I'm going to say elongated / stretched / we could even say tweaked version of whatever the base is. Okay. All right, so again, kind of with this station, even though you're not really doing these in stations, I'd like to leave like 4 and 5 just for you to kind of practice. And if it helps, pull up that website and make your own cylinder or make your own prism and kind of use that to help you answer these questions. And then the 2 on the next page as well, okay? Definitely feel free to use that to explore. For this last station, solids by rotation, we're also not really going to worry with that. If that's something you want to explore yourself, feel free. But for kind of test purposes and final exam purposes, the real meat of the unit today was making sure that you can identify a solid, making sure that we know what parts make up a solid, and then being able to identify cross sections of various solids. Okay, you guys have homework for today. I meant to do this at the beginning too, but I'll pull up and just kind of leave here the solutions for your homework from yesterday as well, just so you can go back and kind of check over those. Then tomorrow, when Ms. Boyd is back, you guys can go over the homework from today. But feel free to email me if you've got any questions. Other than that, feel free to pause this and look at your answers for day 1. And then also day 2 homework as well, since you guys kind of did those together. Okay?